Okay, 3.5 notes. These are going to take you back to Algebra 1 big time, okay? So it's super important that we definitely remember this from Algebra 1 and continue to use it and grow to prepare us for Algebra 2 hopefully next year, okay? So we are going to talk about equations of parallel and perpendicular lines, okay? Remember, parallel lines never touch each other, and perpendicular lines are creating that 90-degree angle. So a couple things I want to refresh your memory about. Okay, you can go ahead and write it up here at the top. We have the equation y equals mx plus b. We know that m is the slope, b is the y-intercept. Okay, we find slope. What I like to think about it as is delta y over delta x. Okay, which is really the change in y over the change in x. Okay, so that's the same thing as saying y2 minus y1 over x2 minus x1, and you can also think of it as rise over run. Okay, that all gives us our slope. Okay, so over here, we're going to identify the slope and the y-intercept and graph the lines in the coordinate plane together. Okay, so again, we have our slope for our top line is 2. The y-intercept is positive 2. So I'm going to go ahead and graph that first. Let me draw in my axis here. Okay, let me use some different colors so we can kind of see the difference here. So we have a y-intercept of positive 2. So that is right here, even though I kind of drew my line off a little bit. And then I have a slope of 2. So that means that it's technically 2 over 1. So I'm going to rise 2 and go over 1. Okay, you can do the same thing going opposite. I'm going to go down 2, but then go left 1. Okay, these are all lines. Okay, so we know that they should be straight. Okay, so that is the first equation there. Okay, and then the slope of line 2, or this bottom one, is also 2, and the y-intercept, though, is negative 3. So I'm going to go down to negative 3. Okay, and then I go up 2 over 1. I can continue in that fashion, up 2 over 1, and that would give me enough points to help me draw this in here. Okay, so then I'm going to look at number 2 here. Okay, I have a slope on my first line of 2 over 3, and my y-intercept is 1. Okay, so let's fill this in here. My y-intercept is 1. I'm going to rise 2 and run 3. So rise 2, run 3. Then I'm going to go down 2, left 3. Okay, so that'll line you up there. There's my first line. Now in the second case, I have a slope of negative 3 over 2, and there is no b there, which means that it is 0. Okay, so that means I'm going to go through 0, 0, and then from that point, I'm going to go I'm going to go down 2, down 3, right 2. So down 3, because that's the rise, negative 3, 1, 2, 3, and then right positive 2. So 1, 2. Now you can go in the other way. I'm going to make the bottom number negative now, so I'm going to go up 3, 1, 2, 3, and then negative 2, run, which means left 2. There we go. So now I have 3 points there, and I can graph that line successfully. Okay, so now what do you notice about numbers 1 and 2, these examples that we did? Okay, well in number 1, you should realize that they have the same slope, okay, and they look to be parallel, okay? And number 2, I noticed that they appear to be perpendicular, and I noticed that my sign switches from positive to negative, and the top and bottom switch on my fraction, okay? So the slopes of parallel lines, we have in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Okay, so same slope, parallel lines. That's what's important there. Okay, slopes of perpendicular lines in a coordinate plane. Okay, remember, if we haven't talked about this yet, coordinate plane is just a fancy word for graph. Two non-vertical lines are perpendicular if and only if, and you notice I've used the symbols for parallel and perpendicular, if and only if the product of the slopes is -1, which means that they are negative reciprocals. Okay, so they switch signs, so like 2/3 and -3/2. Or a different example would be like -2 and +1/2. Okay, so there's that for you. Slope from 2 points, we've talked about this up at the top, but just as a reminder, it is y2 minus y1 over x2 minus x1, as long as your 2 points are x2, y2, and x1, y1. Okay, go ahead and turn the page. Okay, example 2 here, identify parallel and perpendicular lines, determine which of the lines are parallel and which of the lines are perpendicular. So I kind of have it drawn in here for you, some already, just with the way that I took the screen snap of this graph. Okay, so line A has a slope of 1/3. Line B at the top is 0 minus -1 is 1. And on the bottom, you should get 2 minus 0, which is 2. Okay, so that's 1/2. So then line C, your slope is -4 minus -5 becomes +5 over 1 minus -1, it becomes +1. So that is 1/2. And line D, your slope is 2 minus 0 over -3 minus -2 becomes +2. So that would be 2 over -1, which is -2. Okay, so we know that lines B and C are parallel because same slope. And we know that B is perpendicular to D and C is perpendicular to D because slopes are negative reciprocals. Okay, I'm going to go ahead and skip 3. You guys can do that on your own, please, and I will probably check that in class, but go ahead and do that on your own just to save me some time here. Okay, example 3, write an equation of the line passing through the point -1, 1 that is parallel to the line y equals 2x minus 3. Okay, so what you're going to do here, you know what, we need to come back to that one. I'm sorry. Let's go, we gotta skip that one too. Okay, sorry, we're gonna skip down here to the bottom. So this is point slope form of an equation, which we have not talked about yet. So this is if you are given 1 point and the slope. Okay, so this is y minus y1 equals m parenthesis x minus x1. Okay, so you are going to replace y1, m, and x1 to solve problems like this, okay? So what you're going to do, we're going to walk through this. It says write an equation of a line through point 1,5 with a slope of 1/3, okay? So y minus the y1 value is the y value in the point, so that's 5, equals m is the slope, 1/3, parenthesis x minus x1, which is 1. Okay, distribute that through now. So now we need to put it into slope-intercept form. So keep your y minus 5, distribute your 1/3. Okay, and now whenever you go to add 5, okay, you really need to add it in terms of a fraction over 3. So 5 times 3 is 15, so it's really like adding 15/3. So that's going to become y equals 1/3 x plus 14/3. Okay, so write an equation of a line passing through the point 3, -2 that is parallel to y equals 2x plus 3. Graph the equations of the lines to check. Okay, so this right here, parallel to this line, tells you that m is equal to 2. Okay, so you do y minus -2 becomes plus 2 equals 2 parenthesis x minus 3. Distribute your 2 through, and you're going to get 2x minus 6, add 2 to both sides, or sorry, subtract 2 from both sides, and you get 2x minus 8. Okay, I'm going to let you go ahead and graph that, but that's what you need there. Okay? Now, on example 3, okay, same idea. You have parallel to the line, so that means that m is equal to 2. So you're going to do y minus 1 equals 2 parenthesis x minus -1 becomes plus 1. Y minus 1 equals 2x plus 2. Add 1, y equals 2x plus 3 is your answer there. Okay? And example 4, okay, write an equation of the line passing through the point 2, 3 that is perpendicular to the line 2x minus 2 here. Okay, so how you figure this out is that you need to rewrite it in terms of y equals. So that's just going to become y equals -2x plus 2. So then that tells me that my new slope should be the opposite sign, so that means it's going to be positive, and flip it 1/2. Okay, and then you have the point 2, 3. So that's going to become y minus 3 equals positive 1/2 x minus 2. Distribute your 1/2, and you get x minus 3 equals 1/2 x minus 1. Add 3 to both sides, and you get 1/2 x plus 2. Okay? I'm going to finish this video on, these notes on one more video, so just bear with me here and watch the next video too.